All right, so here is your first honors topic for chapter 5. We are going to be, again, finding all 6 trig functions given one trig function and the fact that tangent is positive or greater than 0. So we did some things similar, really similar to this in chapter 4, except this one is going to take a bit more of a twist, and you have probably more angles that you have to go through and be able to find all 6 trig functions. So first thing we're going to start out with is knowing what we're given. Since we are given secant, we immediately jump to the reciprocal function. We know that cosine is secant's reciprocal function, and cosine equals 1 over secant. So in order to find cosine, we have to take 1 over our secant value of -3/2. When you divide by a fraction, you multiply by its reciprocal. So we instead will have our numerator times the reciprocal of our denominator, giving us a cosine value of -2/3. So I kind of want to keep a tally going here. Let me scooch you just a little closer. I want to keep a tally going of the things I know. So I know secant, and I now know cosine, which is -2/3. There's a good chance I'm going to have to keep erasing the middle of my board, so I want to keep a tally of all the things I've found over there. Being that I have secant and I now have cosine, I start thinking like, well, what's my next step after that? I have no more reciprocal functions, and I can't find either of my quotient functions from this, so where else could I go? At that point, your first step likely is a reciprocal function. Second step is likely trying to incorporate some kind of Pythagorean identity. The one that's striking me would be sine squared plus cosine squared equals 1. Why that one in particular? I could use any one that I really want. Knowing that I have secant, I could use a different one involving secant. But because I like to know sine and cosine, because that helps me find my quotient identities, that's the first one I'm going to go with. So I know that cosine squared, I like to do it in order. Sine squared plus cosine squared equals 1. Since I know that that's an identity, the one I'm going to be solving for is sine, because I know cosine. So I'm going to solve for sine in my actual Pythagorean identity. Okay, so the way that I'm going to find this is by substituting cosine with my cosine value of -2/3. Except I'm only substituting in cosine. So I have to leave the square. That's one of the most important things here. Many times we forget the fact that while this was a cosine squared, I'm only inserting a cosine value. So you then have to take that cosine value squared. When we square a fraction, it's again just like any other number squared. When you have 5 squared, it's 5 times 5. When you have 2 squared, it's 2 times 2. So -2/3 squared is -2/3 times -2/3. I'm going to bring this up here. So we still have sine squared minus 2 times 2 is 4, 3 times 3 is 9, negative times negative is a positive, so we are subtracting 4/9. This is sine squared x equals 1 minus 4/9, that gives me 5/9. Except when we go to find trig values, we want to find the actual trig value, not the trig value squared. So in order to find sine, not sine squared, I have to square root both sides. An important thing to remember, when you square root, you have to add in that plus or minus symbol every single time. We can break this up to be the square root of our numerator over the square root of our denominator, right? That's a property that we can implement here. We don't know the square root of 5, so we're going to leave that in a radical. We do know that the square root of 9 is 3. So we are getting that sine equals plus or minus root 5 over 3. But I want to challenge you here. We were given the fact that tangent is positive because tangent's greater than 0. We also now know that cosine is negative. So if we think about all of our quadrants where we say all students take calculus, with this being sine, cosine, and tangent, right? This is all SCT, SCT, SCT. When we're looking for tangent being positive, that only happens in quadrant 1 and 3. So in which quadrant is cosine also negative? Well, that's not quadrant 1. So cosine's also negative in quadrant 3. So we are sitting, our x value is in quadrant 3. In quadrant 3, sine values are actually negative. So we can override this plus or minus and say, nope, we're taking the negative portion of it because we know that when we have a plus or minus symbol coming in here, we have to be in quadrant 3. So we can say, yeah, it actually has to be negative. We're proving why we take the negative side of it and not the positive side. All right, we now have a sine value. So sine is negative root 5 over 3. Let me erase some of this so we can figure out our next move. All right. So I have secant, cosine, sine. My next reciprocal identity I can find, because remember, every time I find my next trig function, I want to go ahead and grab their reciprocal identity. Cosecant is sine's reciprocal identity. So now we are taking cosecant equals 1 over sine. The sine value that we just got done finding was negative root 5 over 3. Again, when you are dividing by a fraction, you multiply by the fraction's reciprocal. We remain with that current numerator, the reciprocal of the denominator. This, of course, is going to give me just negative 3 over root 5. Only we cannot have that root 5 in our denominator, so we have to go ahead and rationalize the denominator by taking root 5 over root 5 multiplied by our original fraction. I cannot multiply by something outside of a radical by something inside of a radical, so I squish them together instead to get negative 3 root 5. Down below, I have root 5 times root 5. I know that that's going to lead me to root 25, and I know that root 25 actually equals 5, giving me a cosecant value of negative 3 root 5 over 5. All right, we are almost getting there. We have 2 more to find. So I've found all of my reciprocal identities of the functions that I have. So again, I have my secant, cosine, sine, cosecant. I'm still needing to find my tangent and my cotangent. Those are my last 2. Lucky for me, since I know I have both of my sine and my cosine, I can instead use my quotient identity in which tangent equals sine over cosine. My sine value, negative root 5 over 3, and I'm dividing this by my cosine value of negative 2 over 3. First thing I see is a negative and a negative. That's going to make it positive. If you have 3's in both of these denominators, okay, and again, they have to be in denominators. So my 3's in my denominator, my 3's in my denominator of my numerator and of my actual denominator fraction. What that would actually come out to be if I went ahead and multiplied by the reciprocal was that numerator or denominator would go up to my numerator, so they would cross cancel. So instead, I can think ahead of that and say, well, I know that's what's gonna happen, so I can cancel these out here. If you don't see that that's happening, you can go ahead and go through this step of multiplying by the reciprocal as well. You in both times will see that you are left with root 5 and 2. Giving me a tangent value of root 5 over 2. Last but not least, cotangent equals now -2/3 over -√5/3. Same thing is going to happen here. Negatives cancel out to be positive, denominators cancel out, giving me 2/√5. Only again, I have to rationalize my denominator because I'm not going to leave this square root in my denominator. Multiplied by the denominator over the denominator gives me √5/√5. 2 times √5, smush them together, 2√5. √5 times √5 would again give me √25. √25 is just 5. Cotangent value 2√5/5. Okay, so while these examples take a lot longer to get through, think what the thought process we kind of took here. You immediately went for that reciprocal identity, easiest one to find off the bat. Then we kind of either transform into wanting a quotient identity. That wasn't possible for the case that we had. So instead we went with the Pythagorean identity. After that, keep pushing forward to find more and more reciprocal identities. Follow up with any last identities you could use. The one cool thing about these is that there's not one process to do any of these. You could take this in a million different directions, just like you can with simplifying trig functions. Okay, remember, there's plenty of different ways to go about them. There's not a wrong way of doing it as long as you're doing it mathematically correct. So if you saw a different path you would have wanted to take with this one, that's perfectly okay. I'm more than okay with that. Just be careful in taking those that you don't lead yourself into a dead end where you can't find anything else past that. That should never happen. You should always be able to still continue using any identities that you know. But yeah, that is the first honors topic.